Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 28, 2025, so about 5 days ago. This paper introduces a new training-free method for text-guided video editing that consistently outperforms existing approaches. The paper is titled STR-Match, Matching Spatiotemporal Relevance Score for Training-Free Video Editing, and as we'll see, the visual results are quite remarkable. The authors propose a new way to measure pixel relationships over time, which helps edit videos smoothly. Also, the authors shared the official implementation on GitHub. Now, if you go check it out, it looks like the code itself is still on its way. The repository is up, but the main page currently has a coming soon message, so definitely one to star and check back on. Alright, and looking at the first figure, you can really see why people are excited. The authors showcase their STR-Match algorithm with some stunning examples of what they call flexible domain transformation. This is where they change the video's subject into something completely different, like turning a cat into a basketball or a robot dog, while perfectly preserving the background and motion. This works because of their new SpatioTemporal Relevance score, or STR score, which is a way to measure how pixels relate across frames to keep the edits smooth and consistent. Building on that idea of the spatiotemporal relevance score, this next figure shows how the whole STR-Match framework operates. So it starts with the source video, in this case, Goldfish, and extracts that all-important STR score, which maps out the motion and structure. Then, as it generates the new video based on the text prompt, Sharks Swim, it constantly adjusts the new video's underlying representation, or latent, to ensure its own STR score matches the original. This forces the shark's motion to mimic the goldfish's, creating that smooth, consistent transformation. So, how is this spatiotemporal relevance score actually calculated? Well, this diagram breaks it down. It shows that to measure the relationship between a pixel in one frame and a pixel in the next, the model combines two different attention maps. It uses a self-attention map, which understands relationships within a single frame, and a temporal attention map, which tracks connections between frames. By multiplying these two maps, and doing so bidirectionally, so both forward and backward in time, it creates a really solid measure of an object's motion and structure. And this new way of calculating motion really shines when you see it in action. This next figure puts STR-Match head-to-head with several other video editing methods. Just look at the cat to basketball example. While other techniques create a blurry mix or a distorted shape, STR-Match cleanly transforms the cat into a basketball, preserving the background and the original lighting. It's the same story with the fish turning into sweet potatoes. The transformation is just much more coherent and visually believable, showing how effective this spatiotemporal relevance score really is. Moving from the visual examples to the hard numbers, this table gives us a quantitative look. It compares their method against a baseline across 4 key metrics. First, their method scores higher on frame consistency and C-clip similarity, meaning the video is smoother frame to frame and better matches the text prompt. Then we have scores for background and motion errors, where lower is better. The results here show a slight trade-off. The model prioritizes a high-quality, consistent edit, even if it introduces tiny changes to the background or motion. This next table really broadens that comparison, pitting STR-Match against a whole field of existing methods. And looking at the bottom row, which is STR-Match with a mask to protect the background, it achieves either the best or second best score across every metric. It's number 1 in clip similarity, meaning it best matches the text prompt, and a close second on everything else. What's really impressive is that it achieves this strong, balanced performance without the complex chain of external models that some other methods here rely on. So to wrap things up, this paper introduces a really effective, training-free approach to video editing. The main takeaway is the new spatiotemporal relevance score. By forcing the edited video to match this score from the original, the model preserves motion and structure, fixing common issues like flickering and distortion. It does this through latent optimization, which is a method of directly tweaking the video's internal representation, making it compatible with many existing text-to-video diffusion models. That's all for today's AI Research Roundup. Thanks for tuning in.